Now, one of the things that's really important to me is to keep things practical. I don't want to talk about theory and not show you some examples of this actually working. So for the infrastructure layer or the switching layer, I'm going to use mininet in this example. Mininet can be downloaded from mininet.org. This is open source free software that you can download and is a great way to develop, share, and experiment with OpenFlow and software-defined networking systems. If you click on the download link, the easiest way to get started is to download the mininet VM image. Now you can install mininet natively from source, but the easiest way is to download the VM image. On the GNS3 community, I have written an article explaining how to run mininet on a Raspberry Pi, if you prefer to do that. But in this example, I've downloaded mininet from mininet.org. So I downloaded the VM, and I'm running this within a hypervisor. You could use VirtualBox or ESXi, VMware Workstation, Parallels, whichever you prefer. In mininet, I can create network topologies, and the most simple is to type sudo mn, which creates a topology of a single switch and two hosts. I'm going to type ping all, which tells the two hosts to ping each other. So that's a simple example of a network topology. If I type net, I can see the connections. So as an example, I can see that host 1 is connected via Ethernet 0 to switch 1 on Ethernet 1. Host 2 is connected via Ethernet 0 to switch 1 on Ethernet 2. Now that's nice, but it would be much better, I think, if we could see that graphically. So what I'm going to do is I'm going to destroy any phantom mininet processes by running the command sudo mn-c. It's good practice to do that. And in this network, I'm running an HP controller. So I'm going to log in to the HP controller, and I'm going to click on OpenFlow topology. And at the moment, you can see that there are no network devices connected. So what I can do in mininet is type sudo mn, use ---- controller equals remote, and then specify an IP address of a controller. In this case, 192.168.56.31, the IP address of the controller, and I'll type ping all to ping between the devices. On the HP controller now, I can see that I've got two hosts with the IP addresses, and I can see how they connected. So these are the IP addresses of the PCs or hosts. If I press N again, I can see their MAC addresses. Press N again, I see a dot. Press N again, I see the IP addresses. This is an OpenFlow enabled switch. This is actually the mininet switch that was created. So if I do net, you can see I have got a single switch. Type dump to see more information. We can see here that host 1 has IP address 10.0.0.1 over there. Host 2 has IP address 10.0.0.2 over here. And we have an Open vSwitch switch. Mininet uses Open vSwitch, and I'll talk more about Open vSwitch in this course and other courses. And we are talking to a controller with IP address 192.168.56.31 using the OpenFlow port number 6633. This number of the switch is called a data path ID or DPID. It's 64 bits in size. The OpenFlow specification states that the most significant 16 bits is set by the vendor. The least significant 48 bits is typically the MAC address. Mininet in this case has specified zeros and a 1. We can see that the manufacturer is Nicira. Nicira is a company that was bought by VMware for over $1 billion, and the hardware version is Open vSwitch. Let's exit mininet and use a larger topology. So in this case, I'm going to specify sudo mininet. I'm going to specify our controller. In this case, however, I'm going to specify a topology of linear. In other words, create a linear topology of 4 switches. I'm going to specify that the OpenFlow protocol used is OpenFlow 1.3. In one of my OpenFlow courses, I'll go through this in a lot more detail, but for now I'll just introduce the various OpenFlow protocols. OpenFlow protocols are from 1.0 to 1.5 at the time of this recording. That doesn't mean that all vendors support those versions of OpenFlow, however. In this example, the HP controller supports OpenFlow 1.0 and 1.3 only. This MAC option tells mininet to use easy-to-read MAC addresses when creating their hosts.